Hi Year 9, just going to go through page 20 and page 21 of the number 1H pack. This page is all about using the skills we've just learned with standard form in standard form calculations. Some of these are quite tricky, especially to do without a calculator, but as soon as you've seen how they start, I'm sure you'll get the hang of it. Okay, so first thing to mention is that when you've got a multiplication of things, it really doesn't matter what order you do it in. So to give you that in another example, if we had 2 times 3 times 4, just going from left to right, 2 times 3 would be 6, times 4 would be 24. Let's think about if we did it in a different way. Imagine if we moved the 2 to the other end. So if we did 3 times 4 times 2, 3 times 4 would be 12, times 2 would be 24. And again, if we did 2 times 4 times 3, you get the idea. 2 times 4 would be 8, times 3 would be 24. So it really doesn't matter what order we do a multiplication in. So how that applies to this is that even though these numbers are in standard form, we can still do the multipliers first, timesing together, and then do the powers of 10 timesing together. Okay, and if I times the multipliers together, obviously that will give me 6 on this question. And if I times the powers of 10 together, I can add the powers. So 3 add 4 would give me 10 to the power of 7. And it's fine to leave your answer in standard form. Sometimes it'll tell you have to, but if it doesn't, you can, because it's a valid way of writing numbers. And that's probably the easiest way to do it. Yeah, of course, the other way is to turn them into ordinary numbers. So this would be 2000, and we're timesing by 30,000. And you times the first couple of digits together, that'll give you 6, and then we're going to need to add on 7 zeros there, because there's 7 zeros in the calculation. Okay, but I'm sure you'll agree there's a lot more writing to do that way. Okay, part B, the brackets are there just to tell you that those are numbers written in standard form. Other than that, you don't really need them there, so you can imagine this exactly the same as the first one. Don't need the brackets. So I'm going to do the 4 times the 2 first. That'll give me 8. 10 to the power of 8 times 10 to the power of 5 is 10 to the power of what I get when I add 8 and 5, so 13. Bit harder with decimals, but if you think back earlier on in the pack, we were multiplying decimals. 6 lots of 1.2 is similar to 6 lots of 12. That'd be 72, so 6 lots of 1.2 are 7.2. And when I do 10 to the power of 4 times 10 to the power of 4, that will give me 10 to the power of 8. So I'm not going to go through all of these. Just look ahead, quickly see if there's any potential issues. Yeah, okay, so so far A, B, C and D, when we times these first digits together, we're going to get a single digit, which is fine. Let's see what happens if we do that with E though. 4 times 3 would be 12, and if I times 10 to the power of negative 7, 10 to the power of negative 2 together, I end up doing negative 7 plus negative 2, which gives me negative 9. Now that might seem like that's an okay way to write the answer, but that's neither an ordinary number nor a number in standard form, because this number is not between 1 and 10. So I've got to turn it into a number that is between 1 and 10. We did this skill earlier in the pack. We've divided it by 10 to turn it into this. So we need to times this part of the number by 10, and that will increase this power by 1. So it will become negative 8. Tricky skill this. Not for the faint-hearted, these last couple of pages, but if you can do it, you know, it's a key skill at grade 5, grade 6. Okay, similarly with part F, I'll just do one more and leave the rest to you. 6 times 4 would be 24. Now if I do the powers of 10, 10 to the power of 10 times 10 to the power of 8, add them together we get 18. That's not in standard form though, so I need to divide the first bit by 10 to get 2.4. I therefore need to times that by 10, the second bit, and that will increase this 18 by 1, so it will become 19. Okay, I'm going to pause the video and fill in the rest of the answers. Now would be a good point for you to pause the video and have a go before the answers appear. Okay, there's the answers to question 7. If you want to pause the video and mark your work. And now we'll move on to question 8. Okay, 8. Very much similar. The only difference is here we are dividing. We're going to do this a very similar way. I'm going to use this space up here to show you how to do this first one. I like to write most divisions as fractions. I find it enables you to see things a bit better. Now when we've got something like this, we can tackle, we would do what we did above actually. We'd deal with the multipliers first, so the numbers in front of the times 10 to the power bit. And we times those together first, and then we dealt with the powers of 10. We're going to do exactly the same here. We're going to divide these multipliers by each other first, so 8 divided by 2 would be 4. And then we're going to divide the powers of 10, so 10 to the power of 5 divided by 10 to the power of 3. We can subtract the powers there, get 10 to the power of 2. And there's our answer. Okay, on the next one. 9 divided by 3 is 3. Note that it's still a times between. It's always a times in standard form. 10 to the power of 9 divided by 10 to the power of 4 is 10 to the power of 5. Okay. This one, 5 divided by 2 is 2.5. Times 10 to the power of 4 will be the power. Okay, again, I'm just going to skip ahead a little bit until I get to one that won't leave me with a very nice answer. So this one, part E, this is the first one I think we get to, yeah, that doesn't give us a number between 1 and 10. So 1.2 divided by 3 would give us 0.4. 10 to the power of 4 divided by 10 to the power of 8, so 4 take away 8 would give us 10 to the power of negative 4, also gives us a negative power. That's okay. But the first bit being 0.4 is not okay. We need to turn that into a 4 by timesing it by 10, which means we need to divide the second part by 10. So this power is going to get 1 smaller. So it's actually going to go down to negative 5. The same thing's happening on this next one. 3.5 divided by 5. Well, if I divided it, if it was 35 divided by 5, that'd be 7. So 3.5 divided by 5 is 0.7. 10 squared divided by 10 to the power of 9, so 2 take away 9 is 7, sorry, negative 7. So I need to times this by 10 to make it 7. I need to divide this part by 10, so this will decrease by 1, so 10 to the power of negative 8. Okay, now I'm going to pause the video and fill in the rest, and you should too. Okay, there's the answers for you to mark. Question 9, similar to question 7 actually, sorry, in that we're squaring them, so we are timesing them by themselves, so we could think of it that way. The other way to do this is to square each part of the standard form. So we're going to square the 3 and get 9, and we're going to square the 10 to the power of 3, and if you remember, if we were just dealing with 10 to the power of 3 squared on its own, we could times these powers together and get 10 to the power of 6. Okay, and the reason we can do that is because if we wrote out what was in that bracket squared, so times by itself, would be very similar to the questions in question 7. Okay, so this one, 2 squared would be 4, 10 to the power of 6 squared would be 10 to the power of 12. I'll just try and find what gives us a nastier answer. Okay, part C, 5 squared gives us 25, 10 to the power of 4 squared is 10 to the power of 8, and that's not in standard form nor ordinary form, so we'd have to change that to 2.5. Divided this by 10, so we need to times this by 10, so it will become 10 to the power of 9. Okay, I'm going to pause it and fill in the rest. And there's the answers to question 9. And the last question on the page, is adding numbers in standard form. This is relatively tricky, I guess trickier than what we've just done. I'll show you quick ways of doing it. You may want to just turn them into ordinary numbers and then add them together though, that's up to you. But here's one way you could do it in standard form. So look at the powers. Usually when they give you a question like this, the powers will either be the same or there will be one difference in them. There'll be a difference of 1 between them. I'll show you why that's important. So 5 times 10 to the power of 4. If I was to write that as an ordinary number, that would be 50,000. 3 times 10 to the power of 4 would be 30,000. So it is the 3 and the 5 are in the same column. Okay, they're both in the 10,000th column. So therefore when we add them together we will get 80,000, or 8 times 10 to the power of 4. So if the powers are the same, you can just add these two multipliers together and leave this as it is. Okay. Similarly on a subtract one, these are both 10 to the power of 3, so they're both in the thousands. So we're just doing 4,000 take away 2,000, which will be 2,000 or 2. And because this didn't change, we can just leave it as is. 2 times 10 to the power of 3. Again, that's similar to part A. Similar to part A. Don't worry about the times 10 to the power of negative 2. It's not a big deal that it's a negative, so this will just be 9 times 10 to the power of negative 2. It's when we get to ones that differ by 1 that's just slightly more challenging. So this number would be 6,000, and this number would be 800. Okay, because the power is 1 less, I know that the 8 will be in the column beneath where the 6 is. So 6 is in the thousands, the 8 will be in the hundreds, and therefore what you can do with these as a little shortcut, well, as an ordinary number the answer would be 6,800, but in standard form you can just put whatever the bigger one is, which is the 6 in this case because that has a higher power, then you can put point and then the next number 8 times 10 to the power of whatever the bigger power was. Has to be the larger power. Okay, I'll just do another one of those. So this one here, even though this only has a 2, it's a bigger number because it's times 10 to the power of 6. This one's an 8, but it's only times 10 to the power of 5. So this one is a subtraction actually, so I'll maybe come back to that one in a minute. Let's see if we can find another addition one. Question I, tricky because they differ by 2. So this is going to be 8 point, and it's not going to be the 3 next because that would be if it had a power of 6. So it's going to be 8.03 times 10 to the power of 7. And if you're not sure why, write them out as ordinary numbers, line them up one under the other and add them together, and you'll see why there has to be that 0 there. Okay, with a subtraction one, these are quite tricky. So this number would be 2 million. So 2 with 6 zeros. This one would be 800,000. So what we need to do is take away those numbers, and that would give us 1.2 million. So one way you could do it, as a bit of a shortcut, is turn this into a 5, turn this into a 20, so we've divided that by 10, we've times this by 10, now they have the same power, and we could do 20 minus 8 to give us 12, then put times 10 to the power of 5, and then adjust from there, so 1.2 times 10 to the power of 6. But however you do it is up to you. Using ordinary numbers is absolutely fine. Okay, so I'll pause here and you can finish off. And there's the answer to question 10. This one, K in particular, quite a hard question. Okay, I'll go through the next page in the next video.